ended the previous video by knowing that hydrocarbons with alcohol can be converted to hydrocarbons with carboxylic acids. And how is this possible? Well, it's all because of oxidation process. Let us understand this process in detail in this video. To understand this, let us take the example of one of the simplest alcohol, that is ethanol. If we add one oxygen atom to this hydrocarbon, the functional group changes from alcohol to carboxylic acid, giving us ethanoic acid. Does that mean we have carried out the oxidation reaction here? Yes, this is understood by counting the number of oxygen atoms in both the reactant and the product. We can notice that there is only one oxygen atom in ethanol, while there are two in ethanoic acid. The alkaline KMNO4 acts as an oxidizing agent, bringing about the necessary conversion. Let us try another example. This time, we take a slightly higher hydrocarbon like propanol. Let us take one propanol and heat it with the same oxidizing agent. What will the product of this reaction be? Yes, oxygen gets added here to give us propionic acid. It's also referred to as propanoic acid. Again here, the number of oxygen atoms in the product is greater than that of the reactant. So do we always obtain carboxylic acid with oxidation of alcohols? Let us check this out with another example. We take 2-propanol now and oxidize it. Look at the product now. The product obtained is not an acid as we expected it to be. Instead, it's a ketone. And did you notice one important thing? Here, there was no addition of oxygen atom, right? Then how can we say it's oxidation? Well, just recall what we said. Oxidation can also be the removal of hydrogen. So even though no oxygen atom gets added, we notice the removal of 2 hydrogen atoms in this case, don't we? Yes, that's the reason why we can say that this type of reaction is also oxidation. So we usually find secondary alcohols giving us ketones on oxidation. What are secondary alcohols now? Well, alcohols are classified on the basis of positions of the functional group. To understand this, let us take the same examples of 1-propanol and 2-propanol. If we observe the structures keenly, we notice that in the first case, OH group is attached to this carbon atom. This carbon atom in turn is attached to another carbon, that is this one. This is the case of primary alcohols. However, in the second case, we find the OH group attached to this carbon atom. And this is further attached to 2 more carbon atoms. That is the difference. And these are called the secondary alcohols. If we have the alcoholic functional group attached to a carbon atom, which in turn is attached to only one carbon atom, then that is called a primary alcohol. Just like this case of 1-propanol. And in the case of 2-propanols, as we can see here, OH group is attached to this carbon atom, which we can see is attached to 2 carbon atoms. That is why it's called the secondary alcohol. So coming back to our point, we have secondary alcohols that usually give us ketones on oxidation. Now tell me one thing, what is the need for converting the hydrocarbons? I mean, why do we need to make new compounds by changing the functional groups? Well, that is because we obtain a variety of commercially important products. Ethanoic acid that is obtained from ethanol is nothing but acetic acid. It is used in low concentrations in vinegar. And we know that vinegar has several applications in daily life. Similarly, propionic acid has applications in the food industry. And what is propanone used for? Well, propanone is nothing but acetone. It's widely used as a solvent for many compounds in industries. Thus, the oxidation reaction of hydrocarbons helps us gain commercially important products. We can now move on to the next type of chemical reaction, that is the addition reaction of hydrocarbons. For that, you will have to watch our next video.